All right. Welcome, everyone. Welcome, welcome. So it is my absolute pleasure to introduce you to Marco Gorelli, who is going to teach us all about polars. And as an absolute pandas addict, I think this will be a very useful talk. So give him a big round of applause.
Cool, thank you so much. All right. Hello, everybody. Woo. How are we doing? Okay, feeling pumped. So mic on, you can hear me at the back, all good? Quite a few enthusiastic thumbs up. All right, nice one. Make sure to leave good reviews of PyData Amsterdam, just like you're giving such enthusiastic thumbs up. So today, my name is Marco Gorelli. I'm here to talk to you about understanding polars expressions when you're used to pandas. Yeah, feeling pumped. So excited to be here. First time at PyData Amsterdam. So I figured I should prepare for the occasion. So before telling you about polars expressions, I'd like to tell you about something I learned about Dutch culture. I'd like to share with you some Dutch expressions. And there's one Dutch expression in particular that I really like. And if you use this one, then everyone will think you're super cool and you'll blend in with the locals. Results guaranteed. And this expression is helaas pindakaas, which literally means too bad. Peanut butter. The peanut butter part does not really convey any extra information. It's just something you add at the end to make it sound a bit cooler, to make it a bit longer, to make it rhyme. I wish I could spend all day telling you about Dutch expressions, but helaas pindakaas, we need to stick to the schedule. Today's talk is going to start with a bit of motivation. Why care about polars? We'll then have a little crash course, make sure we're all caught up with it, know the basics. We'll then talk about expressions, which are the idiomatic way of dealing with polars data frames. And I'll provide you with my mental model for understanding expressions. Now, all mental models are wrong, but some mental models are useful. So my hope is that this mental model can be useful enough that you can then understand what to expect from expressions. We'll cover a quick introduction, multi-input expressions, multi-output expressions, and finally, what happens when you put expressions in a group by context. And then finally, the part of the talk that I'm extra scared of, especially since the room seems to have filled up, all right, let's get the party started, is I'm going to show you how we can re-implement polars expressions in pandas. Gonna live code this, absolutely terrified, but you seem like a friendly audience, so we're going to do it anyway. Finally, all of my talks end in the same way, and that is with some split between engaging Q&A and awkward silence. It's up to you how long each section lasts. Let's get started at the beginning of the talk. A very good place to start. Why care about polars? Polars was started in 2020 as a lockdown project, and it's kind of spiraled out of control since. We see G Research, which is a leading quantitative research firm in London, talk about how for them, switching to polars was not just an improvement, it was a game changer. We see Sky talk about how for them it makes their data processing 10 times shorter. We see Dutch startup Czech Technologies talk about how it saves them money in the cloud. Seeing as we're in Amsterdam, anyone here from Czech Technologies? Okay, one person there in the back. Did you write the blog post? No, okay, well. It was a pretty good one anyway. And as you'll learn in the next talk from Richie as well, NVIDIA considers polars significant enough to gift it with a GPU engine which you can use and install via a new and exciting feature flag. Right, now that we're all feeling pumped about polars, let's have a little crash course. So, the most fundamental data structure you need to know about in polars is the data frame, which is just a collection of series. Each series is a one-dimensional structure, and we have some restrictions on these series. So each series needs to be of the same length. They all need to be named. The names need to be unique. The names all need to be strings. This is already a slight departure from pandas, where you can have repeated column names. And finally, all of the elements in each series need to have the same data type. You can have missing values if you want, but the values that are there need to be of a homogeneous data type. Suppose you're coming from pandas. You might see something like this and try to interact with it by doing what you do with pandas data frames, and that is to say square brackets and names in quotes. And yeah, OK, cool. This works. We get a series out of it. Nice one. Let's try modifying it and then putting it back into the original data frame. And if you try looking around online, you might find documentation for a function called withColumns. So you might try writing assets.withColumns, price doubled equals assets price times 2. And indeed, this is how we can modify a series and then insert it back into a data frame. OK, I can see a bit of a split in the audience, Amsterdam. Some people are nodding along, and some people are looking really suspicious. So if you're an experienced Polars user, please bear with me. I've planned this out ahead of time, building up to something, know what I'm doing. Because just because this syntax works does not mean that you should do it. Let's learn about the idiomatic way of dealing with Polars data frames so that then you too might repeat the phrase, I came for the speed, but I stayed for the syntax, which is something you'll find in virtually every blog post about Polars, every talk about Polars, including this one. A light introduction to expressions. Let's rewrite what we just wrote, but instead of using square brackets and series, let's use expressions. And I'll then like to make the case to you that this is the superior syntax. Let's see if by the end of the talk I can really convey my enthusiasm for them to you. We would write it like this, with pl.call price times 2. Now, I teach Polars sometimes as part of my job, and people very often quickly get an intuition for what's going on here. Like they see this, oh yeah, I'm doubling the column price. Cool, big deal. But this is PyData Amsterdam. You know, I've got a high standard here. So we're not going to settle for just getting a bit of intuition. We're going to go deeper. We're going to try to ask ourselves, what exactly does pl.call price times 2 actually mean? All right, I'm now going to share with you my mental model for pl.call price times 2. So I think different people imagine different things when they see expressions. I'm now going to show you what I imagine when I see expressions. This is my mental model. Maybe it'll be useful to you as well, but it is just a mental model. So when I see pl.call price times 2, what I see is a trade offer, whereby the expression expects some data frame as input, and it gives you back some series as output. To put this slightly more formally, we might say that it's a function from a data frame to a series. All right. Let's go on a little functional detour. A function does not produce a value until you give it an input. For example, lambda x times 2, what's the value of this function? Yeah, nobody knows, but once you give it an input of 3, yeah, then we know what the output is. Once you give it an input of 4, we know that it produces the output 8. And similarly, an expression does not produce an output until you give it an input series. An input data frame, sorry. For example, pl.call price times 2, we're thinking of that as like lambda df price times 2, and when we put that in a select context, it's like we're evaluating that function with the data frame that select was called on. And we can verify this by noticing that the outputs match. So indeed, it's just functions, and they always have been. And the nice thing about functions is that they're kind of like recipes. Like you don't have to do every step immediately. You can analyze your functions beforehand. So they lend themselves really nicely to lazy execution. And if you use lazy execution with Polars, then let's take a quick look at something that expressions enable. Here's an example taken from the scikit-learn documentation. Yes, that's right. Scikit-learn uses Polars in its documentation, in some places. If you want to increase the percentage of scikit-learn examples that use Polars, then this is a good open source contribution if you're into that kind of thing. And as a human, we can look at this and think, wait a sec, if we had to evaluate everything eagerly straight away, we'd be repeating a lot of work. And as programmers, we don't like doing that. And Polars can recognize that pl.callPrice.shift1 is repeated between all of these columns that we're trying to create, and it can just calculate that once, assign it to a temporary variable, and then reuse it in all of these calculations, saving us precious time and resources. This is cool, but I think some of you might be a little suspicious about expressions, because the examples we've seen so far, they're always just operating on one column at a time. in typical data science workflows, you're maybe operating on multiple columns at the same time. Do expressions allow that? Let's take a look. Say you've got a wide data frame, where you've got one column with your date, and then some other columns, and each one has got represents an asset. And the values represent the close price for each day. And you might want to know, for each date, what was the total closing price summed across all assets? There is a Polar's expression that can let us do this, and that is sum horizontal. And it looks a bit like this. We just pass the names of the columns that we want to consider from the input data frame, and then sum them horizontally. If we want to translate that into like a function syntax, we can think of it as lambda df, df abbv plus, and so on. Like we take all of the columns that we've specified in the expression and evaluate these using the data frame that with columns was called on. Now, I've got a little comment there saying kinda, because this isn't actually exact, and if you can point out why, then I might give you a prize. Mind you, I said might. So there's nothing illegal about considering multiple inputs. Like if we've said that an expression is a function from a data frame to a series, then yeah, a data frame contains multiple columns. It's perfectly legit to consider multiple columns from that input data frame, so long as they all come from the same input data frame, and so long as they all just produce, and so long as the expression just produces a single series as output. Okay, Amsterdam, I'm sensing a bit more tension in the room. Some more Polars experts looking at this, dying to interrupt me and say, but wait, what about pl.call ABC? Like, I'm pretty sure I've used this in my code, and I promise you, expressions still make sense, even though it is possible to have things that look like expressions that produce multiple outputs. For example, if we use pl.call ABC times 2, this will multiply all of the columns we've specified there in call by 2. But it produces 3 series as outputs. Like, what? Doesn't this contradict the definition of expression which I've been showing you so far? And in my head, it doesn't, and that's because I don't consider this to be an expression. I consider this to be 3 expressions in a trench coat. It's just one expression. It's a syntactic sugar. It's a shorthand. It's something that gets decomposed by polars into multiple regular single output expressions, and this is how it still makes sense. Like this, you can use pl.call ABC rather than having to write out each one, but you just think of it as being 3 expressions rolled into one. And now it all makes sense, and we can all be chill, perfectly relaxed, knowing that our definition of expression being a function from a data frame to a series is perfectly consistent. We've seen how expressions can use multiple columns from their input, so long as the output is always just a single column. And we've seen how pl.call ABC might look like an expression, but we just think of it as being 3 expressions hiding together under one convenient syntax. But wait, what about group by aggregations? Okay, let's address group by aggregations. Say we've got a data frame of animals. We've got one column with the names of the animals, another column with their weights, and we group by the column name and then pass an expression to the ag function. Let's take a look at what the expression is actually doing, see if we can tie this back to the definition of expression we've been looking at so far. So first of all, we can decompose the input data frame into some sub-data frames, each one of which is given by the unique values of the column name. In each sub-data frame, we can then evaluate the expression, which returns a single series, and then group by ag will rotate that single series horizontally, and we end up with the output shown there on the bottom. Let's put a bit of spice on it. Let's ramp up the complexity just a teeny tiny little bit, and instead of doing pl.callWeight, let's do pl.callWeight.sum. But first, let's take a step back and let's see what happens when we do this in a select statement. In a select statement, say we've got a data frame puffin with some weights of some puffins, and we go from pl.callWeight to pl.callWeight.sum. Notice how the input data type is preserved. Okay, no surprises here, maybe. The only thing that changes is the length. We've gone from length 3 to length 1. Now let's see what happens in a group by context. We've gone from list float64 to just float64. What just happened? Why did the data type change? And why is pl.callWeight.sum behaving differently in a group by aggregation than it is in a select context? And I think this is a perfect example of how practicality beats purity. Whew. And that's because, in theory, Polars could have chosen to return the output we see here on the bottom. It could have chosen for the group by aggregation to return a list float column where each list has got length 1. But is this really what would be useful to users? Like, if you do a group by aggregation, chances are you want a single aggregate per group. What can you do with a list of length 1? Like, Polars could have chosen to give this and then force the user to manually specify explode to explode that column out. But instead, if you do an aggregation, Polars automatically does this for you. And this is how everything ties back together, and we get the output which most of us would really expect and find useful from group by aggregations, which is that the data type gets auto-exploded out for us when we do an aggregation within groupby.ag. Practicality beats purity. Nice one, Richie. There's one more thing I'd like to say about expressions in groupby, though, and that is I'd like to make a little comparison with pandas syntax. I'm not going to say anything about performance, but just if we look at syntax, say we've got a really non-trivial aggregation we want to do, like find the maximum value of column C where column B was greater than its mean per group A. So in Polars, we group by A, and then we pass in an expression which expresses what we're trying to do. In pandas, we can either use apply, and that's probably how most people would approach this problem. If you take one thing away from this talk, it's please don't use apply in pandas. Use pandas if you must, but don't use apply. Unless you really need to, but this isn't really a situation where you need to, because you can also pre-compute the mean of column B beforehand and do 2 group bys. There is also a really magical way of doing it all in one group by, but it involves quite some manual steps. The comparison was just really to illustrate how in Polars, if you understand the concept of expression, you can just pass that into a groupby.ag statement, and it just does what you want it to. And it can even apply some nice optimizations for you. Expressions for the win. But there's nothing magical about expressions. And let's really try to hone that message back to you by re-implementing them in pandas. Let's do this. We are now at the stage of the presentation that I am terrified of, in which I'm going to have to do a bit of live coding. Yikes. Glad that I've been given a headset instead of having to hold a microphone so I can use both hands for live coding, unlike in yesterday's tutorial. I'd never quite appreciated Vim motions so much. All right, say we've got a pandas data frame like this one with 2 columns, and we want to make a new column C taken by adding 1 to column A. How can we do this? Amsterdam. Assign, all right. Somebody's read modern pandas, or Matt Harrison's books. So yeah, we've got a couple of ways to do this. We can use assign, and then we put a lambda function inside. Yeah, this works. Or we could do it using square brackets and series. To be honest, I don't really like either. I don't really like how the first one modifies our data frame, like maybe we didn't want to do that. And in the second one, I really don't like having to write lambda x. It's just incomprehensible to me. I would much prefer it if, in situations where I have to use pandas, I was able to write something like this. df equals df.assign, c equals call a plus 1. And yeah, we are programmers. If we want something, let's try to hack our way towards it. So today, let's see if we can re-implement this in pandas. All right, we've got a bit of time. So we've got a beautiful data frame that looks like this. Our objective is to be able to make a function call, which... All right, thank you for the audience interaction, really useful. All right, I wasn't even full screen. Oh, maybe I was before. So, is this any better? Okay, some more enthusiastic yeps and thumbs up. Nice one, thanks Amsterdam. All right, so we want to make a function call, which, given some column name, it's going to do something. Haven't decided what yet, but we need to be able to then use it in this way, without making any modifications in pandas itself, such that we can obtain the same result that we would get if we were to use assign and lambda functions. Let's do this. So first of all, in order to make this function, I'm going to start by making a class that's going to hold our expressions, called expr, because I've got a lot of imagination, you see. Now I'm going to initialize it with a func object. Now, as we've said a few times, there's nothing magical about expressions. They're just functions, function from a data frame to a series. So let's accept some input function, and let's store it in an attribute underscore func. Now, pandas should not know about our class expr, so we're just going to make this callable. And we're going to do that by implementing dunderCall, self-df. So if we pass in a data frame, we should just return self_underscore func evaluated at the data frame df. We then need to implement some dunder methods. Let's do add, because that's what we need in the example. So if we want to add the current expression to another expression, or another scalar, other doesn't have to be an expression, let's first check. So if other is an expression, then we're going to return a new expression. It's all expressions, where the underlying function, given some data frame, evaluates the current expression at that data frame, and then sums it with other evaluated at that data frame. If other is not an expression, then we don't actually need to evaluate other using the input data frame. Let's do the same with mul. So we've got multiplication. Yeah, take a good picture of them. Nice one. Okay, and finally, we just need to plug this into call. So call is going to return an expression where the function, given some data frame, returns that column from the data frame. Phew. Okay, got a few minutes left, so let's reread this before executing it. Maybe let's just look at the end goal. So here's what we're trying to do. We've got some data frame like this one, and we are trying to match this output here. This is the output we're trying to match, but instead of using lambdas and assign, we want to use our newfound call function. So instead of this, we're going to write call a plus 1. And instead of this, we're going to write call a times call b. Okay, super nervous about executing this, but maybe we're ahead of schedule enough that if it goes wrong, we can do some live debugging. The only thing more stressful than live coding is live debugging, so I hope we don't have to get there. Right, let's just go over this again. So we initialize it with a function, we store that function, we make it callable by just returning what happens if we evaluate that function with the input data frame. We override add by just evaluating both self and other at df. If other isn't an expression, then we don't need to evaluate other. For mul, we can just use multiplication. Okay, let's do it. Here goes nothing. It's either going to be a train wreck or a car crash. And let's see if we manage to get the same output. All right, we did it. Cool, thank you. All right, so as we wanted to demonstrate, there is nothing magical about expressions. We can just think of them as being functions from a data frame to a series. Okay, let's see if I can get back my signal to make this full slide again. Things you don't prepare for. But just for the last slides, I think it's worth it. All right. And I did have a backup slide next, but by the looks of it, we didn't actually need to use it. Everything worked out fine. All right, almost there. All right, we're here. Yes, go back, slideshow. We've got this. You can do it. Okay, anyone got any jokes about expressions? No, it's okay, we've got it. We don't need to fill the time. And if you like the idea of writing expressions and then dispatching to different backends, like pandas, polars, Dask, PyArrow mode in QDF, and more, without having to depend on any, then myself, Magdalena, and Francesco, so some contributors to a library called Narwhals, are going to be hosting a sprint tomorrow afternoon. So if you too want to be part of history by helping to develop this library, then please join us. It's going to be a lot of fun, plenty of issues for beginners, intermediate, and advanced people. So we've covered a lot of ground today, so in confusion, what have we learned about? We've seen how an expression is just a function from a data frame to a series. And being functions, they don't produce values until they're given inputs. And this allows for some nice optimizations, especially if you work with lazy execution. We saw how arguably polars slightly deviates from some notion of perfect consistency, but this is probably a really good idea because it gives you what you intuitively expect and what is useful to you in a group by aggregation context. And finally, we learned about how there's nothing magical about expressions, and if we wanted to, we could re-implement them in pandas. I hope that I was able to convey to you my enthusiasm for expressions, my love for this kind of syntax, and I hope that I've convinced you that indeed it does offer us numerous advantages on top of doing everything with square brackets and series. If I wasn't able to convince you, then I guess that's just too bad. Or as you might say in the Netherlands, helaas, pindakaas. Thank you, everybody. Okay, you've been amazing. Thank you so much.
All right. Thank you, Marco, for such an enthusiastic and very, very cool talk as well.
Oh, thank you.
I don't think it was helaas pindakaas at all. We have time for questions. Are there any questions for Marco? Yes.
Hi. I've seen like an article before on pandas and how to execute functions and other expressions on top of data frames, and there is like a speed chart, like using for loop, list expressions, lambda, vector, stuff like that. Is has polars been calculated on this speed chart? Is it faster than pandas in every step, or is it in between one of these steps of execution?
So if you're just calling out into a custom Python function, so if you're comparing pandas apply with polars map elements, then it's not something I've timed, but I'd imagine it's going to be equally slow. The moment you use the proper idiomatic way of doing it in polars, then yeah, polars can do multi-threading and other fancy things, and that should be noticeably faster.
All right.
Other questions? Over here.
Two very enthusiastic people at the front.
Hello, thank you for the presentation. One actually moment, I don't think you're right about the consistency, because when you apply sum, you apply it not to the series, but to the list, which is aggregated. So it's consistently produced, and it's different functions, I believe. Sum on list, you produce by aggregation, and sum on series.
Yeah, this is fair enough. In my head, once you're there, it's not yet a list data type. So within the source code, there's a flag called returns scalar. And if that is set to true, which it is for these kinds of aggregations, then polars will auto-explode the result for you. So if you write a polars plugin, and anyone who came to my tutorial yesterday will know how to do those, then that's a flag which you can set in your plugins if you also want your aggregation to be auto-exploded. If you don't set it, then polars won't do it for you automatically.
And the second question, if it's so easy to write an expression for pandas, why pandas didn't do it?
All right, I want to propose this to pandas, so please come to the pandas repo and give me lots of upvotes and hearts. I don't know, do you think pandas should have this syntax? Not sure, okay. Well, if you could upvote me then, it looks like I really need your support.
Okay, thank you.
Rodrigo.
Hey Marco, thanks for the talk. You opened with, hey everyone, today I'm Marco. So I'm wondering what's going to be your name tomorrow.
Yeah, I realized that that was a bit of a strange thing to say while I was saying it, but it was too late by then. Couldn't go back in time.
That happens sometimes.
Happens, yeah.
Any other questions for Marco?
Okay, I got a question down there.
Thanks for the talk. Is there any general recommendation? When should we use polars instead of pandas? And just a follow-up to that is, are there already ML libraries directly able to integrate polars?
Okay, yeah, so when should you use pandas or polars? So my general advice is if it's not broken, don't fix it. If you've got an existing pandas project that works, you can keep it in pandas. If you're starting a new project, if you need geospatial data, I don't think that's something that polars has very good support for yet. Other than that, I would generally advise people to try using polars if they're starting a new data science project. ML libraries, scikit-learn accepts polars input, and I think like GBM does, like there's a few that do, like in the end, ML libraries, they typically need to convert their input to something else anyway. So at that point, you're just doing a conversion and you're not losing out on too much. All right, we've not got much time. Got time for one more?
Yeah, I swear this wasn't planted, but could you tell us more about these in-person trainings that you organize, what they look like?
Sure, thanks, yeah. So I live in Cardiff in Wales, but I travel to different parts of the UK to give in-person trainings, and I've given some online. So if you're interested in being upskilled or you want to give your teammates a Christmas present by giving them a polars training course, then yeah, you can write there. And yeah, thanks for the very good question. I'm sure my company would appreciate that when the recording has come out. Keeping me employed. Nice one.
All right, I see one more question there. We still have a couple minutes left.
Okay, cool.
Yeah, I was wondering, because you said that the expressions are like from a data frame to a column or like a series. What about like operations that are data frame to data frame? Are those also more efficient using polars? Like those, yeah, that can't be decomposed into multiple series.
Are they more efficient in polars, like compared to pandas?
Yeah, I mean, you said that scikit-learn supports polars, so I was wondering,
yeah.
matrix operations and yeah.
This is true, but scikit-learn, typically the first thing it does when it receives a data frame is it converts it to a NumPy array, and then they've got their Cython and C Fortran and things, functions that deal directly on the data itself. So they're not doing transformations using the data frames themselves.
Yeah, so it's just like they convert from polars, yeah.
Yeah, exactly. But they are looking at using a bit more of polars internally, at least in part because they're not too happy about pandas potentially taking on PyArrow. But yeah, we'll see how that goes. Hopefully narwhals can help them out.
Okay, thank you.
Okay. Final question? Yep.
I just got a quick question in terms of data stored in memory. So sometimes we do want to use Python packages instead of like some other, say, PySpark packages. Yep. So for that, we do need to download the data to the local machine. So for that sake, you think using polars will give us more data storage?
Oh yeah,
data points?
It's very memory efficient. And yeah, plenty of benchmarks showing that for the same operation, it typically uses a lot less memory compared to pandas. One thing I really like about polars is that it's got both a lazy and an eager mode. So if you want to do everything eagerly, you can do that. I actually know plenty of people who just use the eager mode, and it's already a big enough advantage for them.
So do you know like what's like how in terms of percentage, like just in ballpark, how much data saving that we can, like in terms of storage? Like previously, if we do like 30 million data, a local machine using pandas, and this time maybe?
I don't have an exact figure in my head. I would say it depends. I published a little notebook on Kaggle yesterday showing that if we use polars with query optimization, and we use the GPU backend, we can process larger than memory data sets. Whereas with QDF, because everything is eager, then we're limited by what's in memory. So in that case, the Polar's GPU took like a few milliseconds, and QDF went out of memory. So in terms of the ratio, we're talking about infinitely better, given that the other one failed to execute.
Cool, thank you.
Cool, thank you so much for the question.
All right, yeah, thanks for all these really interesting questions. And once again, thank you to Marco for your great talk. So one more round of applause for him, please.
Cool, thank you so much. You've been amazing.
All right, we have a short 10-minute break.